9-year-old and I last night, I got home. I played golf yesterday afternoon. Had a great afternoon. It was sunshiny. It was wet, but it was sunshiny and warm. And went and played golf with Coach Smith, and had a good time out there in Oakland. And I got home and said, Teddy was like, "Dude, Dad, let's throw the football." And I literally had just walked 6 miles. Okay, so walking 18 holes of golf is a little tiresome. You know what I mean? But anyway, I was like, "All right, boy, we'll play some football." And so we're throwing in the backyard. He has aspirations. He wants to play football this next year. He's going into the fifth grade in the fall, and he wants to join the fifth grade football team. All right. And Teddy never played any kind of football before, but he's got a pretty good little arm, so he wants to try out for quarterback. He wants to be the kid that hands the ball off, or that runs the ball himself, or that throws the ball, gets to touch the ball every time. As a lot of kids want to, I'm sure, when they're little. But he made me really proud yesterday because he said, "Dad, I've got a problem." Okay. He said, "I really," he's like, I want to try out for quarterback, but I'm kind of sad because the quarterback doesn't get to tackle anybody. And I said, "Oh, son, let me tell you, there's this thing called defense that you could play on as well." And his little eyes got big because he doesn't know anything about sports, y'all. So he thought, "Wait, defense? What do you mean?" And I said, "Boy, you could be quarterback for half the time, and then you could play linebacker the other half the time and just murder folks on both sides of the ball." And he's like, "Oh, that sounds great." And so he's excited, and he'll probably end up, being on a team and having a good time, and hopefully not breaking an arm. They had 3 or 4 kids last season on this little youth football program that broke an arm, and I'm like, that's kind of scary. Do what? Yeah. Well, he's got all his friends. He goes to school up in Arlington, and so they've got like a little Arlington youth football team that he would want to play for. I'll get some people dog. Yeah, you do, don't you? We've already had like 4 broken wrists. Oh, and the little kid? Ugh. That ain't good. All right, enough beating around the old bush. Ryan Jeffers, can you hear me pretty good? You ready to roll?
Yes, sir, I can hear you.
All right, that a boy. Hey, look, on Monday we talked about working with fractions and simplifying fractions and operating with fractions. And so what I thought we would do today, continuing on this kind of the same line here, is work on simplifying. And you guys got to forgive me. I think that we left off with example 4 in your class. Am I correct that we did that? Or have we gotten further in y'all's class? I might have gotten off kilter. Did we go far enough to where we started multiplying fractions?
I don't think so.
We haven't done. Okay. So y'all are ready for example 5 then. You guys take notes. When y'all take notes, do you number your examples like I do? No. Anybody who does? Okay, so help me keep track. Or did we do example 4?
Yes.
Have we done example 5? No. Okay, sweet. So we're at where we want to be. Now, in this lesson, we're gonna continue to factor the top and the bottom and see if any common factors cancel out. Okay. And so you look at example 5 with me. I noticed that top right there, I could take a 3 out to begin with. Okay. And I'm left with x squared minus 4xy plus 4y squared. And that kind of smells like a perfect square trinomial. And then I'll take out a 6 on the bottom. And I got x squared minus 4y squared. And that kind of smells like the difference of 2 squares. Okay. So these are 2 of our bread and butter factoring techniques. Actually, we're hitting all 3 of the bread and butter factoring techniques. I just did GCF on top and bottom. And we're about to do a PST on the top and a different squares on the bottom. Those are the ones that we should be just like solid as a rock on by now. Okay. You guys have seen me do this before, but we split the first term up, x times x, split the last term up. Oh, for Pete's sake. Split up 4y squared, baby step it.
Negative 2y.
2y and 2y. And then JT's right. He's reading the writing on the wall. He knows what we're doing. But I was just trying to baby step it, as I said. So x minus 2y quantity squared. And actually, since we're going to be doing a little canceling, notice what I'm going to do here. Instead of using x minus 2y quantity squared, I'm going to write it out twice so I can physically see myself cancel one of those factors out. You know what I mean? All right, and then on the bottom, William Kreitz, can you do our difference of two squares, a binomial times its conjugate?
X minus 2 X.
Good. Now, I got to be honest with you guys. And this always comes up. This always happens. And I'm always curious. And William, not to put you on the spot, I don't have any problem whatsoever with what you just did. But 9 times out of 10, when I ask students to factor the difference of two squares, they always tell me the negative factor first. Is that something that you learned to do last year? Or is that something that you just, like, maybe the textbook does it, or it just struck you that I'll just say the negative one first? Again, not to put you on the spot, but.
Honestly, I don't really know. I just said -2 because I saw first, or -4y.
Yeah. Okay. Gotcha. Like I said, I care not one way or the other, I promise. I'm just a little curious. And so now that we've got it factored out, Santiago, cancel something from the top and bottom. Do you see a common factor that we could scratch out?
Oh, I got up the 3 and 6.
All right, good. So 3 goes into self once, 3 goes into 6 twice. So we do that. And then Nick Pacey, what else cancels out?
Not X and X. It's not Y and Y. It's 2 and
Cash, help him, please. He's floundering.
2.
Justin, help hit both of those boys, please. There. How do you have 102 average in here with an answer like that? What is wrong with you, Cash? Justin. I'm busting chops because I just updated grades and I noticed you were doing really well. You get the thumbs up there, but boo bad on that answer. Okay, Justin, help him out. But we cancel common factors. Cancel something that you see on the top that you also see on the bottom. Yeah, x minus 2y and x minus 2y. Duh. Okay. All right. These are, that's the important, Nick, what he just asked, look, we've got 3 times that parentheses, times that other parentheses, right? And so when we see that multiplication sign, I think I showed you guys a little ball bearing. Did we talk about ball bearings in here? Right? Just keep on rolling, baby. Just cancel till your little heart's content. And so we definitely just canceled out our common factors. What we're left with then, okay, is x minus 2y on the top, add 2, and x plus 2y on the bottom. There we go. So simplifying out a fraction. First thing I do is I factor the top and the bottom. You heard? Y'all try to do this one on your own. Example 6 on your own. Factor and cancel, factor and cancel, factor and cancel. That's what we're doing. Colton, do you have the top factored? When you do, holler at me. And Wilson, do you have the bottom factored? When you do, holler at me. Colton, you got it yet? All right, Colton, I'll help you with the top. I'm looking at -10, and I want a pair of factors of -10 that add up to -3. Attaboy. So you got it factored right there. You didn't even know it. So x minus 5 and x plus 2. Wilson Webster, similarly, how do you factor the denominator? X plus 2, x minus 1. Luke, what can I cancel out from the top and the bottom?
X plus 2.
Mm-hmm. Remember, fellas, it is so important that we learn. I cannot just cancel out one itty-bitty little term. Terms are things that are separated by plus signs, and a plus sign acts as a roadblock. All right. In other words, if I was going to cancel out an x, like look what's left over here. My final answer is x, minus 5 on top, and x minus 1 on the bottom. If I was going to cancel out like an x over here, I'd say, oh yeah, look, there's an x on the top and x on the bottom. Yeah, let's just cancel those out. First of all, wrong, can't do that. But here's why. That x is being linked or grouped together. X and negative 5 are grouped together as the two terms of the numerator. And you cannot separate the terms and just start canceling them out individually, because that divide by sign acts as a grouping symbol. It is saying we are dividing the entire polynomial that's up top by the entire polynomial that's at the bottom. Okay, so that's why we cannot split that up. The factoring has to be there. Y'all, we cannot be dragging our feet on factoring. All right, look at these two trinomials. There were no curveballs. This wasn't anything super challenging. Just average run-of-the-mill trinomials. We ought to be able to jump on that like a dog on a bone. Okay? If you're not there yet, that's all right, but you've got to get better. We got to practice. Okay? We've got to practice. I've been practicing. I was busting Teddy's chops yesterday. He didn't do so well on a math test. They're learning about fractions, right? And so like changing what do you call it, a mixed number into an improper fraction and vice versa. And I was like, dude, we just got to practice some more. So we sat down last night at his little desk in his room, and we practiced. Like I gave him like 10 or 12 practice problems, and we just worked through them together, talked about them and whatnot. And afterwards, he's like, wow, Dad, this feels a lot easier than it did.
I will say that was a hard practice.
Oh yeah, and that's what I told him when the first thing out of my mouth was like, oh, fractions can be hard. But when we practice, we get a little bit more confident. And so last night he went to bed feeling good. Now, whether or not he gets up today and retains it is another story altogether. I guess we'll see. But right, when we practice, we feel a little bit more confident, a little bit better about it. Okay. Now, you look at number 7, example 7 here. I say, hey, look, there's a little curveball, breaking off a little sick, nasty deuce piece at you here. Let's see, the numerator is going to factor out easily enough. Okay, no curveball there on the numerator. Jackson, you want to factor that one? Very good. X minus 8. No hesitation whatsoever. That man knows how to factor. Good. All right, and then we look at the denominator, and what's Quinn? What's a little bit weird or a little bit different about this denominator?
It only has 2.
Okay, so I'm thinking maybe diff of squares, right? Yes. Okay, Jacob? Yeah, it's kind of out of order, isn't it? It's 64 first and negative x squared second. So the way that I'm going to factor that out, remember your difference of squares is a binomial times its conjugate. I've said that about 1,000,000 times, right? What? It's going to be 8 plus x and 8 minus x. Because it's in that order, the 8 comes first. Nick, we paying attention? The 8 comes first and x comes last. Now, there's a note right here, and I use this word opposites. Opposites. Okay, you want to know what opposites are. Okay, so A minus B and B minus A are opposites. If you don't buy that, what's 5 minus 2? What's 2 minus 5? Opposites, right? So 5 minus 2 is the opposite of 2 minus 5. A minus B is the opposite of B minus A. So if I've got x minus 8 and I've got 8 minus x, those are what? Opposites. They're not conjugates. That's a horse of a different color. They are opposites. And so watch, here's the curveball. Here's the trick. What you can do is you can factor out a -1 from one of the binomials. Factor out a -1. Like, for example, I've got room down here underneath, so I'll do it. if I factor out a -1, here I got 8 plus x, that's fine. And if I took out a -1 from that second parentheses, that's like I'm dividing each of these terms by -1. That's going to change it to a -8 and a positive x. And then if we just chose to reorder each of the terms, x plus 8, x minus 8, now we're back to comfy ground where we say, oh, look, there's an x minus 8 on the top and an x minus 8 on the bottom. So in other words, you can cancel opposites as long as there's a -1 that gets left over after the fact. And the way that I'd write my answers up, right, I got x plus 4 on top, and I got a -1 and an x plus 8 on the bottom, which is pretty unconventional, you know. Like here, let me scratch through all of this because I don't want y'all getting confused. It's pretty unconventional to leave your negative down at the bottom. So Hogan, I might like to put my negative out front, you know, x plus 4 over x plus 8. Or heck, I might even get a little creative and put it up top. I might say like negative and then x plus 4 and then x plus 8 on the bottom. Those last two are probably a little bit more conventional. Usually you don't see that right there with the negative on the bottom. But I wouldn't count off if you did. William? All right, so that's an important question. The answer is no. If you didn't hear William's question over this side of the room or online, if you didn't hear his question, he said, now that you've got, like let me zoom in here. Now that you see, hey, look, I've got a 4 and I've got an 8 on the top. What keeps me from canceling out that common 4 is that the plus sign links those two terms together. You saw me in the last way of writing my answer. It is as though there is a parentheses grouping those two terms together, and nary the two shall be separated. All right. Good question, Mr. Brown. Mr. Pearl's got a question. Go for it, Will.
For my final answer, I just got x plus 4 over 8 minus 6. Is that the same thing as you got?
No, it's not. Because if I were going to distribute, that negative, I would have to make it, right? I'd have to make it negative x minus 8 on bottom. You know, the negative would need to apply to both of those.
So you can't just cancel out the negative or the x minus 8 and 8 plus x.
Correct, because they are, let's go back to the original way that we had written it up. There are no two identical factors right here. You look at this screen right here. If the question was, can I just cancel something out right now? There are no two identical factors, all right? Another way of considering 8 plus x would be to say x plus 8, right? So x plus 8. We're reordering the terms using our commutative property. If I came over here with the second binomial and wanted to reorder it, it would be negative x and positive 8. The sign has to stay with each term, okay? So like the negative has to stay with the x. And so there are no two identical factors there for me to say, oh, look, same parentheses on top as I see on bottom, right? But if I identify and say, well, hey, wait a minute, look, these two guys are opposites, then I can say, oh, yeah. You can cancel out opposites as long as you leave a -1 as a factor afterwards. That's sort of the shortcut way of looking at what we did. Okay? All right, very good, very good. By the way, we had a good talk this morning. Alpern kind of walked in towards the end of our, we had a little faculty meeting in here this morning. And one of the things we were talking about is like, there was an expression, as teachers here at Christian Brothers, we're responsible for making sure you guys have well-made heads as opposed to just well-filled heads. And it was something I've been thinking about, you know, like the discussion kind of was, well, you know, I could just dump in a bunch of knowledge and send you on out the door, and that's one thing. But like teaching you how to survive this world, teaching you how to make a difference in this world, that's the ultimate goal of teaching you fellas each and every day. And so the discussion kind of turned around a little bit. We talked more about it. And I said, you know, a lot of my guys, y'all are gonna grow up and never use, you know, like a vast majority of the math that I teach you, right? You might never, after you leave high school, you might never factor a trinomial ever again in your whole life, you know? And I'll be honest with you, if I didn't teach math, I probably wouldn't. So why we do this? Why we go through this? Okay, so just in case, prepare for college, expand your mind. Yeah. So I like what William and what Luke just said. You know, y'all once in a while in life you got to sit, you got to be able to think and do stuff and listen and learn, even if you don't want to, or even if it's boring, or even if you're not interested in it. Training your mind to absorb information to sort of make sense of something that originally doesn't make sense is a greatly important life skill. So while y'all are grinding through like all this business with fractions and whatnot, just kind of keep in mind, man, you are sharpening the knife of your brain right now. Okay, every day we're sharpening that knife so that when you get out of here, you can be a useful and a productive knife. Not a weapon, mind you, but a tool. Anyway, I was just thinking about that. Y'all have had several examples now of simplifying fractions. Let's start operating with fractions. Okay, Joseph, what operation are we going to start with using? What am I doing with these pairs of fractions? See the little dot between them. That means we are multiplying. Good. We're going to start with multiplying. Okay. Today we're going to multiply. Tomorrow, Nick Pacey, what do you think we'll do next? Divide tomorrow. Good. We'll roll up in here on Friday. We'll probably start adding and subtracting. Ooh, doggy. Now, usually you might think that adding and subtracting are easier. Betsy, the second grader, is learning addition and subtraction, whereas Teddy, the fourth grader, is learning multiplication and division. Naturally, when we learn operations with numbers, we go in that order: add, subtract, multiply, divide. When we're talking about fractions, fellas, it's the opposite of that. Multiplying and dividing will be easier. Adding and subtracting is much harder. Does anybody remember why? Because that dadgum common denominator. Oh, that's almost a curse word in some households. Common denominator. But we're going to get there. Okay? We're going to get there. Now, thankfully, with multiplying fractions, as Joseph was telling us what we're fixing to do, it's not that hard at all. All you do, listen to my little phrase right here. It's in blue. I'd write it down if I was you. We multiply the top with the top and the bottom with the bottom. Okay? I was telling Teddy that last night, and he was like, ooh, I like that, Dad. I'll remember that. See, he's confused about how to multiply fractions. And they're doing little number fractions in the fourth grade, like he's doing, 2/3 times 5/9 and that kind of thing. You guys are doing some big boy, polynomials on top and bottom, but the basic rule is the same. You do the top with the top and the bottom with the bottom. However, and I want you to write this down if you haven't written it down already. What do I have written up there in red? It will make your life so much freaking easier if you simplify first. And before I simplify, Ashton, what do I do? Think back to all our previous 7 examples. My first step was okay, so that's a method of, we've been doing the last 2 months, a method of factoring, just generally speaking. William, I didn't hear what you said. Nick, you're not busting anybody's chops, I hope.
I'm not.
When you get here on time, you can start busting people's chops. Ooh. See what I did there? Just a little shot right there, a little kick. All right. Hey, look, when we multiply fractions, yes, it's top with top, bottom with bottom. But if we factor and simplify first, it's going to make our life so much easier. So check this out. I'll do example 8. Let me zoom in here. All right. So I noticed that top right fraction right there is the difference of 2 squares. It's going to factor as x plus 3, x minus 3. Okay. And then down here, I recognize, ooh, that one's going to factor as x minus 3, x minus 4. Okay. So I've got, let's see here, 2x, 3x, x minus 3, and x minus 4. Now, some of y'all are like, wait, what the dump? Where'd that come from? Look, 6 is 2 times 3. X squared is x times x, right? This was x plus 3, x minus 3. And then down here, this was x minus 3, x minus 4. Do you see the rapidity with which we can factor? What is rapidity? It's the noun form of the word rapid. Rapidity, the noun form of rapid. In other words, yeah, if we can factor quickly, now we get to the part where, okay, sweet, let me start canceling some stuff out. Okay, Drake, I'll let you pick a couple things to cancel out. Very good. X minus 3. Okay, and Hogan, is that the only thing I should cancel?
No.
What else? What else can I cancel?
2x.
That boy. Did I stutter? All right. Y'all know who that is? That boy. All right, x plus 3 on top. And then 3x, x minus 4. Hey, do me a favor. I want you to write down on this problem, and just as a note in general, please leave your answers in factored form. Write that down. Please leave your answers in factored form. Don't go to the dadgum trouble of multiplying it back out. Calderon?
For the 2x times 3x,
Mm-hmm.
did you split 6x2 or did you bring down the 2x?
I split, so like right here, I split 6x squared as 2x times 3x, just for visual reference, just so visually we could say, oh, look, there's a 2x on the top and on the bottom. I didn't have to do that step. Like right here, again, right here, we could have had 2x on top, 6x squared on the bottom, and then very likely what I would have done is I would have scratched out the 2, scratched out the 6, written a 3 there. And then scratched out the x and scratched out the 2. Sometimes students are like, wait a minute, what's he doing there? And so sometimes it's nicer. Again, I was telling Teddy this last night. If you're simplifying a fraction, just write out each individual factor, and so you can do a one-to-one cancellation, top bottom, top bottom. All right, y'all picking up what I'm putting down? All right. Here's our next example. And again, Ashton, what's the first thing I want to do right out the gate? Factor everything. Factor everything. Now there's 1, 2, 3, 4. Get your booty on the floor. There's 4 things to factor. Okay. This first one is going to be what method? Magic method. The bottom one right here? Difference of squares. DOS. Good. Top right hand corner? PST. And then bottom right hand corner will be magic method again. Why don't y'all try this one? Why don't y'all give this a little shot here? I'll give you 2 minutes. You're going to have to work quickly. Will Perone, question?
So for example, if the top left were.
Oh, like the same exact trinomial?
Right.
Oh, heck yeah. Yeah. Very rarely would you see that, but absolutely. If the entire numerator was the same as the entire denominator of another fraction, you cancel it out. Will, wait. I don't think so. If I understood what you're asking, I don't think you could do that. All right, but look, we've written it down by now, and we're going to try and factor the top and the bottom, the top and the bottom. I will clue you in on the fact that oftentimes in these exercises, things cancel out, right? We've observed that up to this point. So if I am stuck, listen to me, if I'm stuck on one and I can't figure out the factoring, I'm going to do the other parts, and I'll probably get a clue as to what factors may or may not be showing up. You know what I'm saying? That's what I like to call force factoring. It's like a Jedi mind trick, you know? These aren't the droids you're looking for. Okay? Y'all get that reference?
Yeah.
Okay. So it's like I look at it and suppose I can't factor the top left, the first numerator right there. Let's say I'm stuck. If I factor out these others, I may very well see, oh man, look, a minus 5. Maybe that's a factor of the top that would cancel out. Or something to that effect. And you can sometimes use the problem to answer the problem. I've got about another minute, 10 seconds. About another minute, 10, and then we'll go over this.
On the one above that, did you just multiply all of it in your head?
When you say the one above that, like of the previous problem?
Yes, like when you did the 2x and then the x plus 3, did you put them together?
No, on the one above it, the 2x got canceled out on the numerator and on the denominator. See right here in red how it got canceled out? And then the x minus 3 on the top got canceled out. So I was only left with x plus 3 on the top. And then down at the bottom, we had a 3x that was remaining and an x minus 4. So I just left them, factored out. I did not do any multiplication. 30 seconds, boys, 30 seconds. And I'm going to be putting some of y'all on the hot seat, by the way. So if you, even if you didn't finish the problem, you can still help me get there. All right, Ryan Jeffers, we're going to start with you. Help me factor the top left, that first numerator. How does that factor out?
X minus 9 and x plus 1.
I'm sorry, you're using x. These are a's.
A minus 9, a plus 1.
All right. So you said a minus 9 and a plus 1. If I foiled that back out, I'd get a squared, not 3a squared. So perhaps you forgot to make the 3 come back in there?
Yes, sir. I probably
Okay,
did.
that's all right. I can roll from there. So maybe an a minus 3 and a 3a plus 1. Does anybody concur with that? Yeah? All right, we got -9 on the inner, +1 on the outer. I like that. That looks good. And then Ryan, did you catch that one mistake? You forgot about the 3 coming back in?
Yes, sir, I did.
Okay, cool. And then, hey, look, remember, we're constantly checking ourselves. If I had just taken what Ryan said and written it down, it should jump off the page at me and say, oh, obviously, okay, foiling it back out. Remember, we check, we make sure we get what we started with. Cash money, first denominator. Good. Okay, difference 2 squares, as we said. Let's see here. Who wants the PST? Will Perone's got his hand up. Go for it, Will. So a plus 5. Quantity squared would be how we would normally write it out. But in this context, since we're canceling factors, I really do like to write both factors next to each other. And then lastly, who's got the magic method on the bottom right? William Kreitz?
The a 3a squared.
What?
Or 3a minus 15.
Do you have it factored or not?
3a minus 15.
So a plus 1. And then, I don't buy that. I don't think so. Here's what I think. One of them's going to have a, and one of them's going to have 3a. I'll spot you that. Somebody help me figure out what else should go in there. Okay, William, Brian? Speak up real loud. No, I don't buy that. I don't buy that because if I did the middle right there, look, multiplying the middle two would be like -45a, and that's way too big. Quinn Page, I think I saw your hand up. A minus 5 and 3a plus 1. That smells much better. Oh yeah, smells good. We foil it out and we get what we started. Now, I've got very little time left. I've got 1 minute and 6 seconds. So let's go ahead and cancel in-house. Let's cancel where we see stuff. Okay, so like a 3a plus 1 and a 3a plus 1 and a plus 5 and an a plus 5. And I don't see anything else that cancels. So guess what my final answer is going to be? It's going to be a minus 3, a plus 5 on the top, and there's going to be a minus 5 quantity squared, because there's a couple of them, a minus 5 quantity squared on the bottom. All right. So, hey, that's pretty decent work that we're doing. Tomorrow, I'll have a little screencast put together with some more examples for this, fellas. And then also check some assignments, because on Delta Math, you'll have some homework to do, and you got an ACT number 19, and it's in the quiz category, and that'll be due on Friday morning at 8 a.m. So you'll have some work to do in class tomorrow. In the meantime, great job today, and live Jesus in our hearts. All right, fellas, thank you so much. Y'all be good. Rep that hood.